What's a linear combination? It's a single vector. The next definition we're going to work with is actually an infinite set of vectors. It's called the span. So this is going to be definition in your notes 2.13. The span of a set of vectors. So if we say that m and n are elements of the natural numbers, and we suppose that a1, a2, all the way to an, could you imagine what I'm going to say about those? What did we say about those vectors in the last example, or the last definition? Rm, so they have mango number of rows. The span of these vectors, this set of vectors, we're going to use what we call index set notation. It's a fast way to write an enumerated set. Could you guess what this means? It's a set of vectors where k goes from 1 to n, each vector of which is size m by that context, right? So the span of this set is, and we'll write it like this, the span of the set A, k, from k goes from 1 to n. So it's the set of all B element of Rm such that B is equal to x1, a1 plus x2, a2 plus xn, an for some scalars x1, x2, all the way to xn in R. And another way to say that, could you guess what another way to say that? Are the scalars fixed in the span? What's the one condition for a vector to be in the span of the vectors a1, a2, ak, or an? Each span, well, yeah, that's true. That's not a false statement. When we contextualize the span from the standpoint of a matrix vector multiplication, that will definitely be true. Each vector in the span has to be written as some linear combination. So in order to be in the span, every vector in the span has to be some linear combination. In other words, the span of these vectors is the set of all possible linear combinations. So this is the set of all possible linear combinations of vectors a1, a2, all the way down to an. Later, we're not going to do this today, but I want to set this. Later, we will call this the range of the matrix vector multiplication function. How do you produce a range? And it's over here, right? If I say that f of x, it is a subset, I agree with that. But if I say that f of x is a function, what do I do to produce the range of a function? I run through every single domain space element, and then I see what hits the wall. I'm like a Jackson Pollock painting, right? I take all the paint out of my can and I go, and then the actual places that the dot hits, I say that's part of my range, right? So if I have a matrix vector multiplication problem, how do I find the range of that particular function? I run through every single possible x value in Rn, which means I run through every single possible scalar, x1, x2, x3, all the way down to xn, and then I take the set of all linear combinations by running through all those scalars. How many different choices for x1 do I have? What is x1? What type of object is it? It's a scalar. How many different choices do I have if I want to run through all of them? R, all of R. And that's just for x1. So if I set all of these to 0, x1, I get the entire set of real numbers. Then I set this one to 0 and all the rest of them to 0 at x2. How many choices do I have? R of them. But now I can cross-pollinate. Now I can run through all R's here, all R's there, all R's there. How many different R's do I have? R to the n, right? So we'll get into that. I don't want you to worry about it right now. We're setting this up. What's the span? The set of all possible linear combinations.